All right, so basically, the what this lab was all about was the difference between velocity, acceleration, and position time graphs. So there's a man between a house and a tree, and negative was toward the tree, positive was toward the house, and depending on which section of which what numbers you'd put in each section, the man would move in certain directions and different speeds. So the first few pages were just plugging in numbers and showing the difference between position, velocity, and acceleration graphs. And then it moved on to um, matching certain graphs and answering a few questions like when slowing down, moving towards the tree, the velocity value was getting closer, farther from zero. So it just, depending on which graph that you would be talking about and working on, you would answer a few questions about what the man was doing and what the graphs were doing as well. Um, and then finally, you went into the predictions. So the predictions were based upon you would basically have graphs that were completely empty, and it would say, let's say the man was slowing down and then accelerating. And then you would pretty much just make a position, acceleration, and time graph depending on just that question. Whether you got it right or wrong was just depending on what you predicted. You could have predicted it wrong or right. It didn't. It doesn't really matter in the end as long as you get the correct answer when you actually put in the numbers. Um, so at the end of the lab, have a few questions. So the first question was, how can you tell from a velocity time graph that the moving object has changed direction? It moves from the positive plane to the negative plane. So basically, when the man would pretty much move towards the house and then back towards the tree, that pretty much means that the velocity time graph would go from positive to negative because towards the tree is negative and towards the house is positive. The second question is, what is the velocity of the moment the direction changes? It would be zero because as soon as the direction changes, it goes from positive to negative. Number three, how can you tell from a distance time graph that your motion is steady motion at a constant velocity? If the distance time graph is at a constant slope, so it would basically be either a straight line or it would be a constant slope. So, I mean, because of the distance time graph. Number four, how can you tell from a velocity time graph that your motion is steady? So basically, in the velocity, it would be the same thing. If the velocity graph is at a constant slope, so it'd have to be at a straight line. When the acceleration is zero, can the object be moving while or not? Yes, because when you accelerate or hit a top speed, you can still be moving, but be slowly decelerating. So I related this to like a car. Um, it can be moving. You might not be having any acceleration. So basically, let's say you hit the pedal as hard as you can to the floor, and then you let go. Your acceleration technically is zero, but you are still moving. So that's what I thought about. Maybe, yeah, that's what I thought about. So yeah, that's what this lab was about.